Okay, so I've been solving Leetcode challenges, and I've stumbled upon an easy but still interesting task called the Toeplitz matrix. And well, this is a task about Toeplitz matrix, which is a matrix where diagonal consists of one and the only value. In this case, one. Everywhere is one in that diagonal. But the tricky point is that all the diagonals should have its own, the only unique value. So basically the cardinality of the number of elements in the diagonal should be only one. So, and I've already solved that task several hours ago, and would like to just retrace the solution and re-implement it from scratch because it kind of was a bit bumpy road for me, and currently I want to just share my understanding of that solution and provide it step by step. So, okay, at first I would like to mention that we are dealing with a matrix which is 2D array, and it has some coordinates starting with 0, 0, and going like 1, 1, and then 2, 2, and so that's coordinates of diagonal. And here we can see a pattern that each and every element we are accessing has increasing element, and the value of index is the same for both row and column. So basically, by using that fact, I can build everything around. So everything around this simple statement is just a boilerplate around this statement. So okay, let's just implement all the boilerplate and all the cycles and so on. So okay. Let me zoom a bit first. And well, so currently I'm iterating only over the first diagonal. And well, I need to modify this code somehow to iterate over all the diagonals, not all diagonals, not only over the first one. And well, basically the point is I came to the idea that I will be using the first row and the first column as an entry point to start iterating over diagonals. So first element will be entry point, then second entry will be entry point, and another value will be entry point, and so on and so on. And the same for vertical, like this. Maybe there are maybe elements in other test cases. So let's just start by implementing outer loop. And well, basically, I need some value, and the point is I will be iterating over the first element, and this will be the first line. So yes, and what next? Well, the point here is I don't need for anymore, because I have to have two conditions, and Kotlin, I haven't found actually how to specify two conditions inside for loop. I mean, two conditions to end this loop. And well, that's why instead I will be using while. So let's just start with while. And the condition will be like this. So when I'm iterating over rows, so here I'm iterating over rows. And the point is some value has to be less. So it's just a general cycle without not rocket science. And the point is I have to specify as provided this matrix is not a square matrix, it has different lengths and different vertical and horizontal lines numbers. That's why I have to check vertical lines as well, and that's why I provide another condition. And so the first condition we reach, it will be ending of the loop. Okay, and then let's modify what we have. And then the same. The very basic statement is still here, but I need it to be modified a bit. Just because each time I start from the next element, I have to use the next index from outer loop. And that's why I have to just add another shift to the column. This is a column index. And I have to compensate size by the same value, just because each time I use the next value in the column. And it will be there will be exception if I don't check it. Well, okay, and let's just declare what we have to declare. And well, this is just a basic iteration, and we need to return Boolean, and that's why just by using the fact that everything is correct, eventually I'll return true. So I have to check all the elements. It's impossible to calculate somehow without checking. And by default, we reached that statement. We assume that all elements are satisfying Toeplitz matrix. Well, and one more point. If first element isn't equal to the previous one, just by using that fact, we use fail fast approach. I found the explanation of this approach in one of the books about development, and the point is it's useless to burn cycles, right? Like it said, burn cycles and clock time just to throw away the result. And we can just return the value preliminary. And by using that fact that one of the elements is not equal the previous one, I can just save the resources and don't iterate anymore. So, and well, the point is currently I'm only iterating over just a data structure called matrix or 2D array, and I don't perform any comparisons, any operations, and I need to compare this value with something. And as I had said before, so the point is I need to compare this value with something. And what will be that value? And the point is I compare with the previous element. And well, the previous element will be the first one as well. So I just initialize previous one with just the first one. So it will be always the row number 1 with 0 index. And J index represents just a column. So the J0, J1, J2, J3, and so on. And I have to compare this previous value with the current one and just maintain all the necessary operations like updating previous one and just by incrementing index. So I plus j And well, as I have said before, we just return if a statement is not satisfying our condition. Basically, if the first element we come across is just isn't equal to the previous one, that's why we stop immediately and just return false. So probably there will be some compilation errors, and I haven't covered the vertical iteration. So using vertical line as an entry point for starting iterating over diagonals. And that's why the code will cover only maybe half of the test cases or some portion of the test cases. And currently I'll just run it, not just because I don't know what to do next, just because to check compilation errors and just to check if my two first cases are satisfied. Okay, let's run it. Okay. Oh, okay. Well, basically, I'm not confused, but I just violated visibility scope, and maybe so it's impossible to use this two variables with the same name inside the same scope, and that's why I have to update the code. Well, basically like this, and there also a mistake. Each time I have to start from the next element. That's why I have to start uh, from the current element of the first row. Okay, let's check the fact the code compiles one more time. And there is a typo because indices doesn't require this I letter. Well, and another compilation error, just because I used wrong property, and here I have to use size property instead of indices, because indices is a range, and range is iterated using in loop. But here I I compare two ints, two integer values, and that's why I have to use integer property on both sides of predicate. Okay, well, again, the code is compiled finally, but I still have a mistake. And the point is I confused the variables, and I have to access my matrix just by using J index, not I, and here as well. And so that's the point. That's just a typo, just a vigilant lack of vigilance. Okay, let's check one more time. Okay, the case is handled, and well, the first case is handled, but the second one isn't handled. Well, okay, it's another typo. I've haven't checked it. I use wrong variable here, and well, the point is I have to update it just because I have to compensate. I have to compensate rows I'm iterating over. So let's update it and check compilation one more time. Well, okay, my two expected cases are now finally handled, and currently I'm checking only horizontal diagonals, and don't check. I'm not checking vertical as entry point, and that's why, for example, this one isn't checked. And let's just do it. And well, the point is the code is the same. I just need to iterate one more time over a bit different set of variables. And this time I will be iterating not over columns, but rather about over rows. And I need to update the code accordingly. So I'm iterating over rows and over the first column. This is the first column. And well, the condition stays the same, except no, without exceptions. And here I have to update the code as well, right? Just to iterate over rows instead of columns. And that's it, basically. Let's check it. Okay, I confused you, and well, I still need to update. Now I have to update. I have to compensate um, rows instead of columns when I'm iterating over an array, and that's why I have to compensate in the condition of ending the loop. So that's why let's do it like this. Okay, let's check one more time. Okay, finally everything is fine. All the pivot cases are fine. And okay, let's just try to submit it to check all the test cases. It's checking. Okay, this is another test case where my code failing, and this is just because this 0 isn't matched by this 7. So this is diagonal elements, and they have to be matched somehow. Okay, let's check the code once again and try to find a mistake. Okay, I found the mistake. The point here is I have to start from the 0 each time while iterating over diagonal, not from um, not from element with index I. Just because starting with index I each time I would start like this, not from the entry point, but rather from the some element with shift. Usually it's a diagonal, so it's starting like this and navigating to the element with the shift, but wrong shift, so to say. And I have to fix it in both places. So okay, let's check. Okay, this case number 4 is submitted and passed, and that's why let's submit to all the test results. Okay, the case is submitted. It went to the group with 1 millisecond, and well, this is 70% of the solutions. And I'm not the only person who managed to manage to find the most quick runtime. So basically that's it for today. Thank you for watching. Goodbye. See you.